In this video, we're going to look at how to find averages from a grouped frequency table. Now sometimes when we collect data, particularly if we have a lot of it, we like to group it into classes, and then we can see how many pieces of data there are in each group. This, as I say, works particularly well if we have lots and lots of data. So let's jump into an example and see how we can use one of these tables to find the averages of the data. So this table shows the marks received by students for a physics exam, and the marks are out of 50, and as you can see they are split up into how many people got between 0 and 9. Well, there were 2 people who got between 0 and 9. Between 10 and 19 there were 31 people. Between 20 and 29 there were 73 people. Between 30 and 39 there were 85 people, and finally between 40 and 49 there were 28 people. So how can we use this to find the averages? Well, the first one we're going to look at is the mode, and when we're dealing with groups we don't call it the mode, we actually call it the modal group. And the modal group in this case is the one with the highest frequency, and the group that has the highest frequency is the one with 85. So the modal group is the group 30 to 39. What that means is, of all the groups of data, there was more people in the 30 to 39 group than in any other group. Now, one problem with grouping data is that we don't actually know the actual mode of the data. We have lost some accuracy in our calculations because we are using groups to represent the data, and that's going to be true with all of our averages. For the range, we have the problem that we don't know what the largest mark or the smallest mark is. The most we can say is that the maximum possible range is 49, but we do not know the exact range. So let's have a look now at the mean and the median, and for both of these we're going to need an extra column. For the mean we actually need 2 extra columns in this case. Just like for a normal frequency table, we want to multiply the mark by the frequency to get the total marks for that group. But we don't know what marks they had in the 0 to 9 group. So what we do is we use the midpoint of each group as an estimate for all the values in that group. So we assume that both of the values in the 0 to 9 group have the value 4.5. And then we do the multiplication of the frequency times the midpoint. And in this case that's going to give us 9. And then carrying on in that way, we find the midpoint for each group, and then we multiply each of those midpoints by the frequency of that group. So for this group we get 449.5. For the 20 to 29 group we get 1788.5. For the 30 to 39 group we get 2932.5, and finally for the 40 to 49 group we get 1157.0. So what we've done is we've used the midpoint as an estimate for all the data in that group. Obviously we are not using the actual data here, so the result we're going to get is going to be an estimate of the mean. Once we've done this though, we do the same as we did for a normal frequency table. We find the total of this final column here, and when we add all those up we get 6,336.5, and we find the total of the frequencies, which is 217. So there were 217 people that sat the exam, and the total estimated mark is 6,336.5. So to find the estimated mean, we simply divide 6,336.5 by 217. To find the median, we do a similar process to that of a normal frequency table. And to find the median, we need to have the cumulative frequency. The cumulative frequency in this case, we get 2, 33, 106, 191, and finally 217. We don't need that final column for the median, we just need the cumulative frequency. What we do need to know though is what position the median is in. And the way we do that is using n plus 1 over 2, which in this case is 218 over 2, which means it's in the 109th position. The 109th position is, if we look down the cumulative frequency, the first 106 are above this point, so the 109th is going to be a little bit into this group here. So it's going to be in the 30 to 39 group. The best way to find a good number value for the median for group data is to use a cumulative frequency graph. But from here we can say that it is in the 30 to 39 group. We can also get an estimate of the median, and the way we would do that is to work out what fraction we need to go into the next group. So we need to go from the 106th position to the 109th position. So we need to go 3 data values into the next group. So we need to go 3 data points into that group. And that group has a size of 85. So we need to go 3/85ths of the way into the group. And the group has size 9, so we need to go 3/85ths of the way into a group of size 9, and when we do that we get an answer of 0.3176, and the decimal carries on going. So we need to go that far into this group. The group starts at 30, so our estimate for the median, the estimated median, is going to be at 30 plus that 0.3176, which is 30.32. So that is how we find the estimated averages for data given in a grouped frequency table. The modal group is the group that appears the most often. To find the estimated mean, we find the midpoint of each group and then multiply that by the frequency. Add up that total and divide by the total frequency. And for the median, we can identify the group in which the median lies using the cumulative frequency column, much like for a normal frequency table, and then find what fraction of the amount we need to go into that group to find the actual median. However, for the median, remember, using a cumulative frequency graph is a much better way to find the median than doing it this way.